All right, and welcome everybody to the Daily Space Weather. We've got a massive coronal mass ejection and plenty more to cover. It could be Earth-directed. It's too early to tell. We don't have data from the SOHO. And you can see it propagating down here. Wait till the end of the movie. It just happened a few hours ago. Early in the day today on September 28th. If I had to guess, I would say it's going to miss the Earth to the west. But again, we don't have data from the SOHO yet. Here's another view. This is 94 angstroms. You can see transverse waves going across the entire surface of the sun there. As far as the north-south alignment, it is Earth-directed. But I believe it's going to miss to the west if I had to guess, which I don't. Anyway, massive CME there. Here it is from the Stereo A spacecraft located at Lagrangian point 5, which puts the Earth off to your right. And that's the latest data that we've got on it, folks. We don't see any data from the LASCO C2 or C3. So when we bring this up, you're going to see nothing but old data there. So we won't even play that. Again, there is that massive CME in the Earth vicinity, certainly. And we've had a CME watch for a few days here. Here's some more imagery of this event. It was associated with a C-class solar flare. And here you'll see this spectacular coronal mass ejection, solar flare, propagation of plasma, etc. Here's a close-up of 94 angstroms. That was 304 angstroms. The red-colored view, that's ionized helium. This is ionized iron. Now let's take a look at the magnetic fields. We've got multiple sunspot groups of beta class. Coronal mass ejection watch and solar flare watch continues on, folks. So we're not ending the solar flare or coronal mass ejection watch as a result of that event. The radio flux has come down to 85, I believe. This is the one-year chart of the radio flux. The black line is the radio flux. The red line is the sunspot number. And to all of you grand solar minimum enthusiasts, I ask you, where is your lack of sunspots? If it's a grand solar minimum, why do we see lots and lots of sunspots? Sometimes hundreds. People were forecasting 0 sunspots for years in a row. Let us know in the comments what you think of their forecasts. Anyway, there's the radio flux. Again, it's at 85. And you can see there is a forecast for a geomagnetic storm here. I have no idea what NOAA's talking about once again. But we'll see what happens with the modeling of that. And yes, the LASCO C3 on the Space Weather Enthusiast dashboard and the SOHO movie theater also showing old data. Let's take a brief look at seismicity, which is at low levels. This is a 90-day bar graph. Here's a USGS map. And let's just see where earthquakes have been breaking out. Again, low levels of earthquakes here. Some in the eastern Mediterranean there. South Carolina saw a 3.3, so that's an oddity there. Not every day you see a quake in South Carolina. Leave us a comment if you felt that strange quake. Also, there was one in Lafayette, Virginia. Leave us a comment if you felt that quake. There was a deep quake in the Caribbean at the Dominican Republic. It was a 4.3 magnitude at just over 100 kilometers depth. Also, Western South America in Chile saw a deep quake at a 4.5 magnitude. Indonesia saw a 5.3. That was like the largest quake of the past 24. It's basically a lull in earthquake activity. Next, looking at volcanism. By the way, that's Rupahu, the North Island of New Zealand volcano. That's the Crater Lake. Some information on that coming first. La Palma, continuing to explode, 5,000-foot ash plume over the Canary Islands. Subinosejima, 6,000-foot ash plume over the Ryukyu Islands from Subinosejima. And Rupahu. So aviation code remains green. And the modeled heat flow into the crater lake has dropped from 350 to 400 milliwatts at peak of heating to about 200 megawatts. It's dropped to 200 megawatts from 350 to 400 megawatts. So the heat has been cut in half there. Rupahu looking like it's calming down. As far as White Island, the volcano north of the North Island of New Zealand, sulfur dioxide has increased there. So a downtick on the island and an uptick north of the island. The drop in temperature around the vent area is interpreted to reflect the infiltration of cooler ground and geothermal water into the active vent area caused by decreasing gas pressure around the small volume of magma we believed intruded earlier in the year beneath the active events. So no active ash emission from that volcano, the White Island volcano. Popocatépetl is erupting, 19,000-foot ash plume over central Mexico as it explodes. Sangay exploding, 20,000-foot ash plume over Ecuador. Revenador in that same country producing a 15,000-foot ash plume. Sabancaya exploding, 25,000-foot ash plume over Peru. And no matter how bad things get, don't pole vault the caldera. Do visit the links below this video. Support our channel via becoming a member of the Smash team or maybe picking up some of this sensational merch. But whatever you do, don't pole vault the caldera. It could be unhealthful, and we need the views on YouTube. We're also on BitChute, were you aware? There are exclusives over there that you won't find on YouTube. And if you're viewing on YouTube, press the share button. Tell your friends and foes about the channel. Tell your science noobs and science pros about the channel. The algorithms don't seem to be doing it for us. Also, thanks to our patrons. Most of all, thanks to the Smash team. By the way, here's what the Smash team website looks like. smashamash.com/Smash team. There's all kinds of information there we're only giving to paid members. So there are two tiers, $2.99 and $9.99 per month. For more details, head to smashamash.com. Click on the Smash Team link. smashamash.com/Smash Team. Welcome to the Neo-Renaissance. Our website is spectacular, and we wouldn't have replaced Patreon with anything less. There's our homepage, smashamash.com. Today's featured product is available by clicking the merch link, smAsho merch. If you click that, you'll find this. Our Redbubble shop. Today's featured product is the purple Mansa shirt. Yes, why? Because I'm wearing one at the moment. Here it is. And we're reminding you to Mansa. Yes, to all of our American viewers. Mansa, make Earth not suck again, and make America not suck again. Mensa, Mansa, etc. Make whatever, wherever you're located. Make it not suck again. It's up to you. Not huge bureaucracies that can't even get out of their own way, much less make healthcare decisions for you. By the way, we regularly stream live to Twitch as well, twitch.tv/smashamash. We'll be streaming a cosmology and a meteorology segment while we're in the middle of recording this video. So here's the GOES magnetometer over the past 3 days. We're getting into the realm of magnetic data now. The 3-day chart of the GOES magnetometer showing some high readings here from the GOES 17 especially, as well as some arc-jet moments where the satellites had to maneuver, creating plasma, and possibilities of data loss as they're measuring magnetic fields, and the plasma from their exhausts can affect that. That's what the arc-jet moments are. And there is another current sheet polarity coming. So here's the top view ecliptic plane field plot, looking at the heliospheric current sheet and its polarity. South pole shown in red, North pole shown in green. And we bring up the latest image. Earth is about to move into a South pole current sheet. If it hasn't already, this video was shot with 1 hour and 23-minute old data. Here's the line of sight view, also showing you the solar magnetogram. And it certainly looks like there is a South pole current sheet imminent. Could already be here. It'll be here soon, certainly. Here's the sun's B field shown in blue, these blue potential field surface source lines. Those are the sun's B field. And for you new viewers, those of you who don't understand magnetohydrodynamics, the B field is the field that goes through the magnet. This magnet being the sun. This also shows coronal holes, South Pole in red, North Pole in green. And there are some rotating in here in the southern limb, barely making it to the equator, not quite making it to the equator, actually. And expect to see lots more coronal holes in the near future. Here's the best view for coronal holes. It's 193 angstroms from the SDO, the Solar Dynamics Observatory. And this also shows great detail of the transverse waves created from that C-class solar flare and coronal mass ejection we showed earlier, coming from down there. Just spectacular. Coronal hole rotating in down here, which is why we put up this frame. So that CME could be headed our way, folks. We just don't know yet. It's a little bit too early to know. So here's our flare monitor, and the coronal mass ejection watch and flare watch is indeed still in effect. We've got quite a few named sunspot groups that made it all the way up to 7 on the computerized flare probability monitor here. I counted at least 4 when I did show prep. So again, where's your grand solar minimum? Where is your grand solar minimum? We're supposed to have 0 sunspots for like years in a row. I'm not seeing it. Sounds like nonsense. Sounds like a completely implausible theory. Here's the GOES X-ray flux, and this is the flare that seems to have created that coronal mass ejection. It's quite significant, and we'll be waiting to see data from the SOHO, LASCO C2 and C3. We may see some relativistic particles striking now, actually. We're seeing the biggest spike here in the proton flux we've seen in quite a while. That's something to keep an eye on throughout the rest of the day. And when I say eye on, well, the pun is intentional. Next, we'll look at the real-time solar wind, where a lot of people have been hallucinating coronal mass ejections despite none striking. What we see here is the onset of another coronal hole wind stream. So here you can see the density making it up to about 25 protons per cubic centimeter, then dropping down as the velocity comes up, the standard signature of a coronal hole wind stream. This one's pretty high speed here, and we could indeed get into geomagnetic storm conditions, especially if we see this top pane, the red line, drop well into the negative territory. If we see that go to like -4 or something like that, that could cause geomagnetic unrest or geomagnetic storms. Anyway, current conditions are just under 6 protons per cubic centimeter for the solar wind density, solar wind speed 520 kilometers per second, quite fast. It's a high-speed coronal hole wind stream, or a coronal hole high-speed stream, if you prefer to call it that. KP index currently only at 2. That's a measurement of global geomagnetism. Let's take a look at the geospace as modeled by the Space Weather Modeling Framework. We should see a slight increase here in the magnetohydrodynamic pressure toward the end, coinciding with that several hour-long steady uptick in the solar wind speed. Pressure looking pretty homogeneous here over the past 4 hours. That's 4 hours of data. Next, ground magnetic perturbation. Since there's a polar excursion going on and people are very frightened of things that aren't scary at all, we show the ground magnetic perturbations in the form of geospace delta B. This is 4 hours of data, just like the last pane. What a pain, people who don't understand the physics, but want to make all kinds of predictions about things that they don't understand. It's pretty sad. Anyway, that's 4 hours of ground magnetic perturbations. Cheers. Here's where stuff's located in the solar system. All the planets are on one side, and Mars is feeling pretty lonely over there, although there are a couple of rovers to keep it company. Anyway, we'll advance this 1 week, approaching another new moon. There's where things will be on October 5th. Here's a star chart. Mine's facing the south because I'm facing the south, and so is my sofa. And you can see the moon just crossing the galactic plane there. As it travels across the ecliptic, the path the sun will take across the sky, this yellow line, the galactic plane is the blue line. Again, it's in-the-sky.org. If you want to make yourself a star chart, check it out. Today's cosmology segment will air after the daily space weather video later in the morning. YouTube.com/smashamash/playlists. You'll find over 200 in our cosmology segments playlist. Let's take a look at charging hazards. There are some minor charging hazards here over places like South Florida, the Western Caribbean, Central America, and Mexico, and soon to move into the Central Pacific. Here's the relativistic electron flux over the past year reported by Solon.info. Moderate levels here, almost reaching warning levels yesterday. These are the measurements by the GOES 16 and GOES 17. It's a 3-day chart of the electron flux, and we're expecting another dip in the electron flux here. So I would tend to agree with this forecast here. The green boxes are the forecast. The yellow diamonds are the observation. And we're going to show the total electron content next. First, here is the Earth's Van Allen belts and distances in miles to things like geosynchronous satellites, which is what your GPS unit is talking to. GPS satellites are located at about 12,500 miles of altitude. And this is the total electron content between your handset and said satellite. Things looking fairly organized here. They might get a little chaotic, as this coronal hole wind stream is quite high speed. Next, a diagram of the Earth's atmosphere in terms of locations of the ionospheric layers, like the D, E, and F layers. The F layer, located at about 300 kilometers, is our next pane. Don't be a pain. Understand the ionogram, showing vibrational frequency in megahertz. So some significant high-frequency anomalies kicking up here over places like South America, really all along the equator here. Making it all the way up to 14 megahertz there. That's 14 million vibrations per second. Anyway, there's the latest image from 9 o'clock. Things looking more normal at that moment. Here's the anomaly map, departure from 30-day median in megahertz. You see a lot of blue on the map here. Those are high-frequency ionospheric anomalies. And also some low-frequency ones that are around the South Atlantic anomaly, which is actually here over the South American continent now. There is another minor anomaly down here by South Africa, another weak spot in the magnetosphere. Anyway, there's the latest image. That's 9 o'clock. You can see some high-frequency anomalies showing up there in the Central Pacific Ocean there, right over the equator. All right, let's do our bonus features. First thing we're going to look at is the Lermonth ground-based solar observatory here, located in Lermonth, Australia. And you can see that coronal mass ejection solar flare event, that C-class solar flare that occurred. A great view of that in hydrogen alpha imagery. And let's take a look at some high-res imagery of the closest star. So here's the latest refresh of the intensity gram. And this sunspot up here is looking pretty well defined. It's definitely a beta class. It's got 2 significant umbrae. Down here we've got at least 2 more groups. Those are all beta class. That one there is alpha class. So at least 4 sunspot groups, folks. Here's a colorized magnetogram. Coronal mass ejection watch and solar flare watch remain in effect. We'll close out the video with some additional full disk views of the closest star. This is 304 angstroms. Ionized helium. Give it a moment to initialize. It's well worth it. So once again, spectacular imagery here. And choosing facts over fraud. Choosing observations over nonsense. Choosing information over imagination. This is a composite view. This is 304 and 171 angstroms. We'll close out today's daily space weather video at 171 angstroms. My personal favorite wavelength. Once again, thanks for tuning into the channel. Congratulations on realizing that it exists, and may that solar wind be at your back.